Okay, this is the continuation of Lesson 99 test review. The video stopped on us, so I'm going to continue right where the last one left off. So we're at number 14. So let's do this one. These are quadratic equations that we are going to factor and simplify. So we've got here x plus 7 and x plus 4 for the top. So you'll just do one little part at a time. So I did the numerator, then you're going to do the bottom here, the denominator. You will factor out this negative x. You don't want to leave something negative x squared. So we're going to factor out a negative x, which will leave us with x. When we factor out a negative, and then a negative here, then we have a negative, right? Because this times this will give us positive x minus 5. So if you just redistribute and do it, you check it, and it will look like this when you check it. So then we're going to times, and here we're going to factor out an x because we have an x common in each term, and we're left with x squared minus 3x minus 10. And then here on the bottom, we're left with x. We get x plus 4 and x minus 3 to factor this one right here. Okay, now we can start. Well, let's do this one. This is in the form now that we can factor out, or rational expressions. And let's go and see what that's going to be. Well, that's going to be x minus 5 and x plus 2. So that's what we want in there for this one. You'll leave this x right here. So I'm going to let me rewrite this. So we're going to have the x and the x minus 5 and x plus 2. Now we'll look and see what we can cancel out. And it looks like we can cancel out this x plus 4 and the x minus 5 we can cancel out. And this x, and this is a negative x. So we're going to have to just leave the negative, but we can factor out the x. So factor this x, or cancel out that x. And then we want to just leave this negative here, so we're left with x plus 7, and this is times x plus 2, and then our denominator is just x minus 3. And that's as far as we can go. That is the answer right there. Okay, let's see which one's next. Number 15. Let's do number 15. Number 15. Number 15 is 81 equals 4x squared. And they want to solve for that. Well, how we're going to solve for that is we look at it and we see that it is squares. Everything in there is a square. 81 is a square, 4 is a square, x is a square. Is it a difference of two squares? No, but we can make it that way. We can minus 81 and minus 81. So we can have 0 equals 4x squared minus 81. Now, when we have this, we know that's all a square, a difference of two square. We have a plus and a minus. We take the square of 4 is 2, square of x is x, square of x squared is x, then 2x again, right? And then 81 is 9 and 9. Okay, now we're going to set these equal to 0. We don't want to forget about the 0 here, because we're going to actually solve for it, okay? So when we solve for it, we take 2x minus 9 equals 0. This one. If this is 0 times whatever this is, the answer is going to be 0. And we solve for this. This is going to have two answers, remember. Plus 9, divide by 2, divide by 2. And this is one answer, a plus 9 over 2. Then if this is 0 times whatever that one is, then the answer will be 0. So we're going to set this one equal to 0. So you set each one of them equal to 0. Minus 9, you have 2x equals negative 9. Divide by 2, and this is the other answer. Both of those answers will solve this equation and make it true. Okay, number 17. F, this is a function here, f of x equals the square root of 3x minus 4. Okay, they want you to determine what the domain and the range is. With the domain, well, I guess, and I'm not sure they're asking for the range. Let me see. 17. They're asking for the domain. So if you're solving for this, this is our domain. Remember, this is like our y equal to. So this is like something we can graph, but we're not going to graph it. But when we solve for this, the answer under the square root cannot be negative, okay? So the domain will be all numbers of x that will make this not negative. So the way we do that is we do 3x minus 4 equal to 0, okay? And then whatever we solve for x that's equal to 0, we're going to have the x is greater than or equal to 0. That will be our domain. All those numbers that are greater than or equal to 0 will satisfy this equation, okay? Will satisfy this function. So we just have to solve for it. Plus 4 equals 4. Divide by 3, divide by 3. Okay, this is the answer right here that makes this 0. We want x to be equal to 0 or greater than 0. So this number is the answer. So any x value that is 4/3 or greater is going to satisfy this equation and make this a function. So when you're graphing it, which that's beyond the scope of this class, this can't be negative under here. And as you go on in Algebra 2, you will see why. But right now, you just have to remember this cannot be negative under the square root sign. Okay. For a function. Can't be negative for a function. Okay, let's do number 18. Number 18 is we need to write the equations of the already graphed lines. So this line here is 1, 2, 3. This is on 4 here. And this line right here is just graphed as y equals 4 because every point on this line is going to be 4 of y. When you graph any point on this line, y is equal to 4. Okay? Just like if you had a line going this way and say that was 2 right here, this will be x is equal to 2 because this vertical line, every single point on here will be x equal to 2. So if you don't understand it, just memorize it. The horizontal lines will be y equal, the vertical will be x equal. Okay, then they have another line down here for you to look at. 1, 2, 3. So this one's at -3. That is our y-intercept. And then it also intercepts the x-axis at -3 right here. So this is this line, and you're supposed to write the equation for that line. Our equation is, remember, y equals mx plus b. B is where it intercepts the y-axis. So that is a -3. X can be any xy pair on here, xy. We need the slope now. We need the slope. How do we get the slope? We do rise over run, don't we, when we do slopes? Slopes are equal to rise over run. So we go to this line. We're kind of doing it backwards now. We're doing it the other way. We go to this line at the B, okay? And we've got to determine the slope. So our slope is going to be 1, 2, 3. That's a rise of a +3. Right? 1, 2, 3. And then we're going to go over 1, 2, 3, a -3. Okay, what is 3 over -3? That is the same as a -1. You can say -1 over 1 if you want. If you put -3 over 3 here as the answer, that would be fine. The answer key, I think, has it y equals -x minus 3. They just leave off the -1 over 1. Whatever, I know you understand it if you do it this way, or even if you use this one. So the equation of the line is y equals a -1 over 1 slope, x minus 3. That is the equation of this line right here. Okay, what's next? That was 18. We're going to do 20. Let's do number 20. Number 20. Okay, these are radicals again, and we are multiplying radicals. So, okay. What I would do first, what is that? Oh, we're actually multiplying and then we're adding 2. How about that? Okay, so what I would actually do is you can multiply all the whole numbers here if you want, right? That's how we do radicals. And then these are like our xy values. So we're not adding them, so let's go ahead and do the multiplication first. We want to do this first. So that's 12 times 5 is going to be 60 here. And under the square root sign, we can just put them all together if you want. 2 and a 3 and a 12. Let's go ahead and simplify the 12 and put it into prime numbers here. So we have 2 times 6 is 12, and then 6 is 2 times 3. Okay, so now we can go ahead and simplify this again. Let's take these, pull it out, and this one, and we get 60 times 2 times 3, and that's left square root of 2. And then over here, let's do this. We don't want to forget this part. This part is 2 square root of 8. Well, that's not simplified. You've got to have 2 times 2 times 2. We're going to pull out a 2 here. So over here, we're going to end up with 2 times 2 square root of 2. This one, we end up with, what is that? 120 times 3 is 360 times the square root of 2. And this becomes 4 times the square root of 2. So now we're adding, we have like terms, don't we? Square root of 2, square root of 2. So we can add those two together, and we get 364 square root of 2. And that is our answer. Okay? That was number 20. Let's do 21. 21 is 3 times the square root of 2, and we're going to have in parentheses 5 square root of 2 minus 4 square root of 42. Okay. Let's go ahead and distribute here. We'll just go ahead and do that first. We want to distribute. And we end up with, we multiply the whole numbers 15, and underneath here is going to be 4. Okay, and then we'll simplify later, and then we're going to drop our minus down. We're going to do this, multiply the whole numbers 12, and then multiply underneath here, which will be 84. Square root of 84. Okay, now we're going to simplify. So we've got this is 2 times 2, so we're going to have 15 times 2, and under here will be the square root of 2. This will be just 15 times 2, sorry. This is 2 times 2. We pull it out, there'll be nothing there. So it's 15 times 2, sorry about that. Minus, what's this going to be? Prime factorization. Well, we're going to have, let's see, what are we going to have here? 2 and 2, 4. Let me do the little factor tree here so we can. 2 times 42, 2, 21, 3, and 7. That should be it. 2, 2, 3, and 7 underneath the square root. You're going to pull out the 2 here. You're going to make it 12 times 2, and then the square root of 21. Let me make sure I'm doing this one. 21. Okay, so now we have 30 minus 24, multiply those two, square root of 21. There's no like terms here. There's not a square root over here. We can't combine these two, and that should be the answer right there. We're done with that one. Okay. Okay, now we're going to do number 22. We're going to solve by graphing. Number 22. 22 is y equals x minus 4 and y equals negative x plus 2. Okay, so we're supposed to graph these two lines here. So, the first one, the b is the negative 4. 1, 2, 3, 4. That is the point you start. That is the y-intercept right there, negative 4. Then, if there's nothing in front of it, we've got a slope of 1 over 1. So that's rise, run. So we're going to rise and run 1. So there is the second point. We can draw a line, and that is the, that is the first one. Okay, let's plot this one now. Well, this one is y is 2, or b is 2, sorry, the y-intercept b is 2. This is a negative 1 over 1. So that means we're going to rise negative and then over 1 positive right here. And that's going to be right here. And then wherever this point is, which I can't really tell on mine, but when you do this graph, wherever this point is where the solution that you could put back in as x and y value, that point, whatever it is, and I'll tell you what it is, I'll just look it up. Number 22, the point is, what's the point? 3, negative 1 is what that point is. Well, mine doesn't look like that, but 3, negative 1. But when you get done with this, yours should look like 3, negative 1. Your graph, okay? So this one I plotted, this one I plotted, and then when you, if you put those answers in your x's and your y's for these two equations, they will both be true, okay? They will both work because this point is actually about right there. So let me fix that. So it's a little down. It's 3, 1, 2, 3, negative 1. That's that point right there. Okay, that's number 22. Let's look what's next. 23, we're not doing 24. Scientific notation. Let's do this one. Number 24, scientific notation, simplify. Okay, so we have, let's write the problem, 22,000 times 10 to the negative 7, and the next part is times 500, and then underneath here we have 0.0011, and then we have 0.002 times 10 to the 14th. Okay, so we're going to simplify these. Okay, so we have to change these to look like significant figures. So we're going to change this right here. And we need it to look like this. So what do I have to multiply this by, this 2.2, to really be that number? Well, I have to do this. 1, 2, 3, 4. I have to multiply it times 10 to the 4th. Okay? If I multiply 2.2 times 10 to the 4th, I will get 22,000. So that is this part, okay? Then you've got to, don't forget that, put the 10 to the negative 7 on. And you have done this part. 5. You want 5 to look like this, significant figure. So what I have to multiply this by to look like this? 1, 2. I've got to multiply it by 10 to the 2nd. And this is equal to your 500. Okay, now let's do down here. I got to look, this has to look like a significant figure, so I'm going to have to move it 1, 2, 3. So that's going to be times, and what did I do? I went from here to here, well, it's got to be 10 to the negative 3, right? Because it's got to get smaller. It's got to be this same number, okay? Then I'm going to do this on the this here. This one needs to move 1, 2, 3 to be a significant figure of 2.0, and to do that, this is going to get smaller. I'm going to have to have 10 to the negative 3 here, right? This will look like this. That's what we wanted to do, and then times 10 to the 14th. Okay. So the top here becomes 2.2. We add those. We have times 10 to the negative 3. We're going to do this one as, where am I at? Right here. This is going to stay the same. Okay. And this one on the bottom is going to be 1.1 times 10 to the negative 3. And this one here on the bottom is going to be 2.0 times, add those, that will be 10 to the 11th. Okay, I'm running out of room. So anyway, when we do this, well, these you can just cancel out here. Everything's being multiplied here. So you can have, you're going to have 2.2 divided by 1.1. And then you're going to have 5.0 divided by 2.0 if we're going to put all those numbers together. And then we're going to times and have 10 to the 2 over 10 to the 11. So this will simplify into, let me see, I did it here. This is, wait a minute, did I do this? What happened? Okay, let me make sure I'm doing, okay, so this becomes, just a minute, 22, this, when you multiply these all out with your calculator, you should get 5, okay, and then times, and this one you move up here and it'll become negative, right? So then you'll have 10 to the negative 9. Okay, that is the answer. 5 times 10 to the negative 9. Okay, let's do number, which other ones are we going to do? 24. I've got 25, 26, 27, and 28 left. Okay. Okay, 25. On 25, we're going to do x plus 4 plus 3 over x minus x plus 2 over x squared. Okay, these are all being plus and minus. Okay, they are also not an equation. So we are looking to change all the denominators to be alike. Okay, so what we have on 25, we need the denominator to be, okay, x is part of the x squared there, so all we need is x squared. We need the largest of what we have there, and then x plus 4. So that is the common denominator that we will use on this one. This is different. It's not an equation. We find the like denominators, the common denominators, when we're adding, subtracting fractions. So this one here needs the x squared on it, so we're going to multiply x squared here and x squared here, so this becomes x cubed. This one needs another x and x plus 4. We're going to do that to the top and bottom, x plus 4. So this becomes plus 3x, x plus 4. This one needs the x plus 4, top and bottom, x plus 4. So this is x plus 2 and x plus 4. Okay, now let's see. We need to probably simplify that somewhat. So let's see what we have. Let's go ahead and simplify this here on the top. So we have x3, we have 3x squared plus 12x. Then we are going to multiply those together, and what do we end up with that? We end up with x squared. Let's just go ahead and do it like this. X squared plus 4x plus 2x, 6x plus 8 for this one. Okay, what else can we do? Looks like, well, the bottom stays the same. Bottom is staying the same. Let's just work with this on the top. So we don't have anything else to add to this x to combine with this. We have a plus 3x squared, and this one will be negative. Remember, we've got a negative in front of this, so all these signs are going to change here. So this is going to be a negative x squared. With this one will be a 2x squared then. This is 12x. This will be a minus 6x. Don't want to forget this minus because it changes everything. And that will be a plus 6x. And then you will have a minus 8 right here. So let me double check that. And that's right. And then you just need to tack on the bottom here. And that is as far as you can go. Those are a little bit messy. There's your answer. There you go. That's number 25. We'll do number 26. I'll do number 26 for you. Number 26 is P over 6 minus P plus 2 over 4 equals 1/3. Okay, now that is an equation. That is an equation, so what we're going to do with an equation is we're going to cancel out denominators, so we are going to find the LCM, the common denominator down here that everything goes into, and that looks like it's going to be 12, isn't it? Everything will go into 12 here, so we're going to multiply everything by 12 to eliminate that denominator. And that gives us a 2 there, and a 3 here, and a 4 here. This is 2p minus 3p plus 2. Put that in.